Thanks for the introduction. As the guy said, my name is Alan Keogh. I lead up Crowley Carbon's CoolPlanet Group's energy division, which is called Crowley Carbon. Just very briefly, just to give you an overview of who we are, I'll only inflict one slide on you, you'd be glad to hear. So we're a group of companies under the banner of CoolPlanet Group that our mission is to build technology and educate people about how climate change can be solved. And we do that across three main pillars. The first is energy, and that's why I'm speaking to you today from this group, transportation and education. So in the transportation group, we convert a range of different types of electric vehicles to EVs. And education, our mission is to educate teenagers and young people about the impacts of climate change and what they can do about it in a positive way, and not that we're all doomed. And so on the energy side, really, we've been in the energy efficiency business for the last 10 years or so, delivering energy efficiency solutions and services to industry across the world. So we operate in about 10 different countries across the world. And as part of that, we have an energy efficiency platform, energy intelligence platform, which we call Clarity, which I'll talk to you about today at various points. So as I mentioned, we're coming really from the customer perspective, and specifically the industrial customer perspective in terms of energy efficiency and demand side management and demand side management. And as per the theme of the discussions today, the Internet of Energy, Digitization and Industry 4.0 obviously is a big topic generally, not just in grid management and energy efficiency, but right across industry to deliver value across reliability, capacity, uptimes of plants. And I suppose one of the things we've seen over the last couple of years is there's a lot of talk about Industry 4.0, but not really a lot of talk about what the outcome for the typical plant manager is, or the typical continuous improvement manager in an enterprise is. And that hasn't kept pace with, if you look at the consumer, the kind of quality of products, software products, and the consumer has been benefiting from over the last 10 years or so with Netflix and Uber. Really, the industrial world hasn't kept pace with that in terms of the quality of products that plant managers can use to drive efficiency in their plant and ultimately drive continuous improvement. And that's a shame, we think, but we think it can be fixed, and we're going to talk about that today. So really, in reality, a lot of what plant engineers are doing, or what they were doing 20 years ago, 30 years ago, going around reading meters manually, collecting data manually, looking at SCADA systems that are not connected to anything, just sitting in control rooms, not connected to anything, looking at 2 or 3 different data points as opposed to 3,000 tags that are on the SCADA systems, and not utilizing the full range of data that's available in the plant to make the plant more efficient from a energy efficiency point of view, and also going forward from a demand management point of view. As I said, there's a lot of talk about Industry 4.0, big data, digitization, etc. And really the response from a lot of the industry, whether it's food and beverage industry or pharmaceuticals, is kind of, so what? What's it going to do for me today? How's it going to make my life easier? How's it going to make my plant more efficient? How's it going to reduce my cost base? And I suppose our purpose in life is to deliver those answers to those people who are running those plants. And just to frame this discussion, this is, many of you will be familiar with the technology lifecycle adoption curve, which was posited by Geoffrey Moore about probably 20 years ago or 30 years ago in a kind of seminal book called Crossing the Chasm, which has been updated a number of times. And really what he posited was that in any new technology adoption, in the life cycle of that technology, there's 5 different cohorts of users. And the early adopters of any new technology are really the people who believe in the why of the technology, why this is going to make the world better, or my plant better, or my enterprise better. But they're a very small part of the market, maybe 10 or 15% of the market. And to go mainstream, you really have to convince the bulk of the market, which are termed pragmatists and conservatives, that you have a solution for them that will make their life better, whatever the technology is. So the analogy on EVs is, 5 or 6 years ago, as Tesla was really starting to ramp up, the public charging network was not in place. But early adopters are willing to put up with that pain of, worrying about range anxiety, etc., because they believed in the mission of EVs and how they would change the world. And really, we're getting to the point here where EVs are starting to become mainstream. Obviously, they're only 6% of the market still in Ireland, but they are growing and growing. And really, for them to be mainstream, they've got to convince the pragmatists and conservatives that they're not going to run out of electricity halfway between Dublin and Cork, and that they can get their car fixed if it breaks down easily. And big data, really, we think, is not making the jump in industry across what's called the chasm from the early adopters to the pragmatists. And really, that a lot of that is down to the use cases. Why should I take on big data? How's it going to make my life better? And what Geoffrey Moore posited was, really, to make that jump across the chasm, you have to do two things. One is you have to have a whole product that the pragmatists and conservatives feel secure that they will get a solution and they won't lose their job if they buy you. But also, you got to pick a beachhead. So you got to pick a narrow niche of the market, win that market, and then expand from there. And that's what we feel about big data and digitization and Industry 4.0 in the context of industrial users and industrial plants. So kind of an example of that is, obviously 10, 15 years ago, energy management systems became quite pervasive for 5 or 10 years ago. And really, a lot of times they were kind of a failure in their deployment. And this graphic kind of maybe outlines why that may be so. They were launched with a lot of fanfare. They're going to solve our problems in terms of energy management. They're going to solve our problems in terms of our CSR goals. And then how it's going 6 to 12 months later was, well, nobody can remember the password to the EMS and really nobody uses it. And that's a failure. And, we're not, as a society and a business, going to reach our goals if we don't have the right data to manage energy efficiency on industrial facilities. So just to go back to the technology lifecycle adoption curve for a minute, the other metaphor that Geoffrey Moore used for crossing the chasm was DDay. So over here in England in 1944, the early adopters are here. They want to win Western Europe from the Nazis, but to do that, you don't jump straight into Berlin because you won't win the war that way. So you pick a beachhead, Utah Beach, Omaha Beach, etc. You win that beachhead and you grow from there. And really, I suppose our what we believe is that, to drive digitization and Industry 4.0 in industrial settings, the beachhead should be energy and sustainability. And the reason for that is it's relatively unpolitical. You're not messing with the process. Anytime you start to jump into the process and, affect yields, capacities, quality, etc., that can be quite a political for users in industry, whereas energy efficiency is relatively unpolitical, but it is becoming more and more important. Obviously, you look today, carbon is about 55 euros a ton. So energy efficiency and carbon management sustainability is increasingly on the agenda, even from a cost point of view, as well as every other reason. It's sub-year, 1-year paybacks are possible. So there's a lot of low-hanging fruit in these industrial facilities that could be delivered using the right tools and digitization, etc., to deliver value in energy. You can relatively easily demonstrate value, and that's another big thing. Is well, I buy all this new technology and sensors and digitization and platforms and big data. Really, what am I going to get from it, and how do I demonstrate that value? And it's possible to build what we call a whole product solution, which I'll talk to you about in a couple of slides. So the concept of the whole product was that really for those mainstream users, conservatives and pragmatists, to adopt a product, and really a lot of what we talked about today is new technology, but really consumers at the end of the line, whether it's domestic or industrial or commercial, they've got to adopt these technologies and products and be incentivized to do so. And the products have to be so good that actually it makes it easy for them, and it becomes easier when they adopt the products. And the idea of the whole product is that you've got a core product, which is the core platform. You've got an actual product and an augmented product. And all of these things need to be in place in order for the customer, the consumer, the user to feel that they have a whole solution and that they're not at risk if they adopt your product. In terms of the context of energy efficiency, what does that look like? Well, the core product is a platform, whatever that platform is. But you've got to tick a lot of these boxes around here. You've got to be able to show value very easily. You know, what have you done for me lately? You've got to be able to engage users easily and make sure that they're adopting the product. Back to the point about, well, does anybody have the login? Obviously, you don't want that to happen. You roll out new software and a platform and nobody uses it. You've got to be able to integrate with various different systems in the plant, whether it's right down to the boiler level or the refrigeration level or the production information systems, and pull all that information together that you need in one place. You've got modular capabilities to expand it over time. So really, all of these things need to be in place to have the whole product in energy efficiency digitization. And to kind of summarize that journey a little bit, is the idea is of crossing the chasm is the early adopters are over here. You need an invasion force, which is the whole product. So various tanks, planes, ships, etc. You got to pick the beachhead. In this case, we're suggesting energy efficiency. But once you get onto the beachhead, there's 5 fatal flaws that I'm going to talk about over the next couple of slides that you need to avoid once you've won the beachhead. So these are the 5 fatal flaws that we see in the deployment of these technologies and platforms, and I'll go through them one by one. So the first one is that whatever solution you put in place, it's deployed transactionally, which means, you know, you just buy it. It doesn't sit as part of a workflow. And the kind of paradox for buying these systems is that you cannot, in the case of energy management systems or energy efficiency, paradox is you cannot digitally transform your energy management and sustainability process without software, but EMS software will not digitally transform your energy and sustainability management process. So obviously that sounds contradictory, but really what it means is you can't just buy these things off the shelf, give people a login. It's got to sit in a process of delivering value over time. And it's got to sit in whether it's a new workflow or an existing workflow in whatever business that is, to deliver efficiency and energy efficiency over time continuously. So the kind of desired workflow that we see our customers want and we assist them putting in place is this. So if you think about a typical plant, it's got a lot of data sources. I'm just going to put on my pointer here. It's got a lot of data sources over here. So it's got plant control systems, SCADA systems, it's got lab information systems, it's got various meters, it's got utilities in the form of compressed air, boilers, etc. It's got production information system and various logs that are taken manually by operators and maintainers. And ideally, or aspirationally, all that data gets collected continuously at high frequency, good quality, clean data. And it's brought up to a central point, which we call the collator, which could be a person or software or both. And that collator starts to generate really high quality data reports using digital twins to say, you know, look, this is what's happening in energy, this is what's happening in production, this is what's happening in quality. And at this point here, the data is presented in such a nice way that people can identify problems and opportunities for efficiency in the plant easily and quickly. At that point, they take action. So the action can be either operational change to change a set point, or reduce temperatures in an oven or a cold store, or increase temperatures in a cold store, or they take some CapEx action, so which means they need to do some design, detailed design, implement the project, whatever that project is, say a heat recovery project. And ultimately, on both routes, they've got to confirm the effect, so make sure they're finding savings or delivering savings, and then maintain the savings over extended periods of time. And it's one of the challenges with energy efficiency that we've seen a lot over the years is, you know, you can save $1 million in a plant, you go back 3 months later, and that $1 million is $300,000 because people like to change things back and change set points and not maintain things. So it's very important when you've invested that money and you've saved that carbon that you continue to do so. But in reality, what we see a lot of the time in industrial settings is this type of workflow. So the SCADA, as I mentioned before, is not connected to anything. It sits in a control room. The lab information system is absolutely independent. There's no meters, or the meters that are there are not accurate. The boiler sits on its own at the back. Nobody ever looks at it. Logs are never collected, and production information is completely a different system. And if they are collected, all that data typically is collected manually, infrequently. It goes to several different people. There's no central collator. Maybe they generate some consolidated reports, but they take a long time, maybe 30 days. It's very difficult then at this point to see opportunities and problems because it's just taken such a long time and the data is missing most of the time. And it's very difficult to get to this point to decide to take some action to do something more efficient because you just don't have the data. But if you do, there's a lot of fear of change because, well, we changed that set point last year and quality went crazy, so we're not going to do it again. We like our jobs too much. And it's very difficult to get to this point because there's no teams of engineers hanging around waiting for projects to implement. Typically, there's no finance either. So it's very difficult to get to this point, confirming the effect because you haven't done anything, and then it's very difficult to maintain the effect over years because you don't have the data. So really, back to the point about the system or the improvement system or the platform has to deliver this workflow. And it has to sustain it over years, and that's the reason why you do this. You don't just do it to have a quick win or tick a box. Really, it's got to deliver this workflow and deliver opportunities consistently over years. The other fatal flaw we see is systems integration. So there's just not enough data in the platform. You know, you're just taking data from one source, and you exhaust what you can do with that data very, very quickly. And it's messy to merge these two worlds together, the OT world and the IT world. So in the industrial setting, the OT world is everything from boilers to refrigeration plants to conveyor belts to SCADA systems. And a lot of that stuff it's old in industrial plants. It's not networked. So really the trick is to network as much of it as possible, gather it up, and merge it at the cloud level, in our case, with the IT world. So ERP systems get production information, quality information, etc. Put all that information together so you get the full rich context of what's happening in the plant and what you can do from an efficiency perspective. And then the third fatal flaw we see once you've got off the beach is deploying what we call a system of engagement rather than a system of record. And back to the point about consumer grade software, we're seeing that more and more, that industrial software is getting better and better, but it's still a long way behind the experience you have when you use Netflix or Uber or some piece of, or some app like that. And really to drive adoption and engagement. And this is what it's all about. You know, we can have the best policies and systems and procedures in the world, but ultimately, whether it's domestic users or consumers or industrial plants, the systems have got to drive adoption and engagement in what we're trying to achieve here as a bigger society. And to do that, the user experience has to be good and better than it is at the moment. And it's got to force collaboration or encourage collaboration between different people, stakeholders in these plants. So really, the fatal flaw to avoid here is to not build a system that people don't want to use or don't want to collaborate across their businesses in. An example of this from our own platform is what we call a Kanban board, which is highlighting various different issues in the plant. In this case here, air compressor consumption is exceeded. It's copied, it's pulled in the experts and the plant manager and the subject matter experts and the utilities manager into this issue. And when they dive into this, they get lots of rich contextual information to solve the problem as quickly as possible. So they get lots of spec sheets relating to that compressor, so they can dive into exactly what that compressor is, lots of photographs, but they also get performance data. So in this case here, they get the trends of how this compressor was operating over time. So really it forces collaboration, and as they dive into this problem, they can solve it as quickly as possible and take that opportunity to drive efficiency. The other fatal flaw, the fourth one, is really driving adoption again, so that people actually, get to the home run of not just gathering data and visualizing data, but ultimately getting insight and taking the final step, which is, fix the problem, whatever that problem is, or deliver the opportunity that's been identified. And then finally, on the fifth fatal flaw is being clear about what the value is that's being delivered, whether it's technical value, energy savings, kilowatt hour savings, or productivity value. How much time are people wasting walking around a plant, gathering data, reading meters, filling in spreadsheets when they go back to their office, for that nobody ever looks at. So one of the things we're very militant about is driving value on the platform. In the case of us, it's Clarity as our platform. This is a case of a large steam consumer in an edible oils processing facility. So you take soya beans, you extract the oil from the soya beans. And in this case here, we had a digital twin running on the platform, which was indicating that this piece of steam using equipment was using significantly more steam than it should have. We worked with the operators to converge the actual steam consumption with the optimum steam consumption over this period of time here. And then we rack the savings up here. So we said over that period of time, the savings are 1,500 euros, which is over a week or so, or a couple of days. So quite a significant saving over annualized. So, but to have that value upfront, explicit, that plant managers and operational directors can see that value. And it's a real feedback loop to say, look, we should be doing more of this, and we go deeper and deeper, do more systems integration. And from the productivity point of view, we're quite militant about, understanding how people and engineers are spending their time collecting data sources, slicing and dicing it, writing reports that nobody ever looks at. Automate all that stuff for them, and allow them to save hours and hours every month. In this case, 75 hours a month. So finally, just back to this workflow that we talked about during the presentation. So I mean, ultimately, the outcome of doing digitization and delivering these tools is to deliver this workflow. And there's four main steps to do that, which we work with our customers with. And the first is, very powerful OT, IT integration, automated data collection, scraping data from as many sources as possible, correlated data, contextual information, bringing it up to a platform, which in our case is we call Clarity, which organizes, cleans, presents the data, allows you to build digital twins in the platform that identify problems and opportunities, like the excess steam consumption example I showed. And then using that data and the digital twins to drive analysis with data-led specialist engineering services, and then ultimately take action and have this effect as a flywheel. So it's continually pumping out opportunities for savings and value delivery in the industrial setting over time. So hopefully I'm on time, Bob and William, but that's me.
Thank you, Alan, for that presentation. I suppose just one question I would present at this point, Alan, is what would be the typical lead time to do a scoping analysis of, say, an SME that are interested in going down this road, and then not only the lead time of scoping it out, but what do you see as a typical lead time to roll it out and prove the efficiency of it?
Yeah, it's a good question. I'll answer with a good engineer's answer, which is depends. So for an SME, very quickly, look, scoping 2 to 3 weeks and roll out maybe another month or so. For an industrial plant, a big industrial plant with a 20 million euro energy bill or dollar energy bill, it can be longer. But again, it depends on the plant. You could have some plants with just no data available at all, and you got to build that infrastructure and put in the sensors and the meters, etc. which obviously can take time. But there's other plants who are more data ready, and we are getting to the point, albeit it's a minority of plants, whereby they are scraping data out of all parts of the plant and bringing it up to a data lake in the cloud. In that case, really, it's a matter of a week or two to make that connection. Once we've got over the IT security protocols that any multinational company will have in place, the actual technical bit is a week or two. It's not long. Obviously, complying with security protocols that the multinational customer might put in place takes longer, and it's kind of as long as a piece of string sometimes. So the answer is it kind of depends, but anywhere for a big industrial plant for total 2 months to 6 months, I would say.
Okay, and then just to follow up on that, for say an SME that is interested in this, what would you recommend? Do you recommend to scale the introduction of it, start small, try it out, pilot it out, and then replicate?
Yeah, we would, especially for the SME, where look, in reality, they're not going to have resources to focus their attention on this. Really, SMEs just want to know a number. Am I on target where I should be? Based on weather or footfall through the business or whatever it is. Am I using more energy than I should? Condensing that down, giving them one number, really, to me, is, we don't operate in the SME sector. We're purely in the industrial sector. But for the SME sector, for the contact points we've had with it, really, it's down to give the business owner one number. Are you above where you should be for for the footfall, for the weather, for whatever it is that drives energy consumption in your business?
And then someone else has submitted a question, very interesting one. Obviously, there are those who would be very interested in a manufacturing setting to implement this. And one of the typical questions that's always asked is, what's the payback? How do you demonstrate the payback?
Yeah, well, I can take the second part first because it's easier. So the second part is we demonstrate the payback on the platform. So if you remember the example I gave of the steam reduction, so we converge the actual steam consumption of a piece of equipment with the digital twin, which was basically saying this is the optimum steam consumption for the production throughput at this particular moment in time. We do that on the platform. So we say, okay, when you converge the two, you make a certain amount of savings multiplied by your cost of steam, which is dictated by your cost of gas or oil. We put that front and center on the platform to demonstrate that value. In terms of the overall payback of this kind of approach, it's typically in the range of, and it kind of depends on how much sensors you need to put in. So if you have a plant that has lots of steam use in the plant, you got to put in steam meters. Steam meters are expensive compared to electrical meters. Electrical meters now, especially the kind of new generation wireless ones, which are very easy to deploy and you don't have to wire them up because they're wireless. But steam meters are still expensive. You got to cut into pipe and flange them and wire them up and all that kind of stuff. So on a plant with a 3 million, 4 million euro energy bill, with no sensors, no meters, you could be spending 100,000, 200,000 on meters and connecting them up. To give you that granularity of data, to be able to build the models and compare the actual consumption versus the models. But typically what we would say is the savings that would come from this kind of approach range from 2% to 10%, in that range. 2% really is not very engaged end users. You're giving them lots of information, but maybe they're not doing anything about it. 10% is from people who are, look, this is brilliant. This is changing their working life. We're going to implement every opportunity that's identified by the system. So if you said 10%, well, say the midpoint, 5% on a 4 million energy bill, that's 200,000 savings, which is, if you spend 200,000, it's a 1 year payback. So we would typically expect to be in the 6 month to 2 year payback range.
Thanks, Alan. A few questions, just to go back to previous questions, and some of them are quite